Hi, today I want to continue the series about the nRF51822 from Nordic Semiconductor. And today's topic is secure DFU OTA via BLE. Secure because it's using asymmetric cryptography with elliptic curve encryption. DFU stands for Device Firmware Update, OTA, over the air via BLE, via Bluetooth Low Energy. Before you can use device firmware update over the air, you have to build a bootloader. Because the bootloader have to build up a Bluetooth service, you have to use the soft device and flash both to your nRF5 hardware. And if you want to build a secure bootloader, you have to use an external library from Ken McKay called micro-ecc, micro-elliptic curve cryptography. Then you can build your own application as usual, but if you want to use DFU again, it's best practice to use the same soft device as the bootloader. And there's another point we have to mention, because the bootloader cannot flash into all nRF51822 devices, only if the device have at least 32 kilobyte of memory. So you can only use the QFAC variant or the simple BGA type. Before we start the practical demonstration, more infos can be found at GitHub and at Blogspot. So check the links in the description. Before we can build our bootloader, we have to generate our private key. And this can be done with a tool called nrfutil. And if we want to use it, we need Python, and pip installs the Python packages. So first we have to install Python and pip if it's not on our system, and on my Ubuntu installation I type sudo apt-get install python pip and wait for the download and installation. Then, if necessary, we can upgrade pip with pip install -- upgrade pip. Now we install nrfutil via pip with sudo pip install nrfutil. With nrfutil, now we can generate our private key with nrfutil keys generate and the name of our private key file .pem. And afterwards we can generate the source code with the public key file for our bootloader. And also, before we can build our bootloader, we have to download a GitHub library from Ken McKay, micro-ecc. So we use git clone and the URL. So now we can change to our bootloader directory and build our secure bootloader with make. And after the make is finished, we have the bootloader.hex. Now we can flash our bootloader into the nRF51822 chip and display some debug information with PuTTY. Now we can build our firmware as usual, or in my case I built a demo application and build it with make, and afterwards I use the nrfutil with package generate to build a zip file for the encrypted DFU file, and this we can upload to our mobile device and use for our DFU OTA via Bluetooth Low Energy. And now let's test our DFU. We take our mobile device, open the nrf connect application, scan for our bootloader application and connect it. And afterwards we use DFU, select our zip file and start the transfer. Now we can see the data transfer, and after a while we can see that the application is run and the service, DFU service, is disconnected because it don't runs anymore. Now we can try to build a bigger package with our application, the soft device and the bootloader to update all three of them. If you want to start your device with the bootloader again, you have to press the programmed key. In my case, it's key number 2. And afterwards we press the key and start the device. Now the bootloader goes online and we can connect again. Now we select our big package with the application, the bootloader and the soft device and start the transfer. But after a while the transfer breaks. So we can read the debug message. There's no way to fit our DFU zip file into our device. So maybe we need more RAM memory, and this is only available into the nRF51822. So there's no way to do this in the 51 series. Or maybe there's a trick, but I don't know it. So thanks for watching today, and I hope you enjoyed the video and you learned something. So give me a thumb up, and if you want you can subscribe to my channel or read my documentation under Blogspot, and the source code is available under GitHub.